The University of Colorado at Boulder has created a simulation for circuit building. Go to their website and download the circuit building kit. Once you have the kit ready, you will start building circuits using different size resistors and different values for batteries. It's very easy to do. Start by dragging a wire over. The little dots represent electrons. They are not moving currently because this circuit is not complete. Drag over a battery and connect it to the wire. Connect another wire. And finally bring over a resistor. Once your circuit is complete, you can see the little electrons moving. You can change several different values in the circuit. By right-clicking, you can change the voltage to much higher. Notice at higher volts, the current flow is much higher. You can also change the value of the resistor. You can change the resistance to much higher. Notice how that slows down the current. You can also change it to much lower. Let's add a light bulb to this circuit. First, break open the junction and add the wire and resistor, or actually you can add another wire right here to close your circuit. Notice how bright that light is. What happens if we change our voltage? If you reduce the voltage, notice how the light dims. If you increase the voltage, the light gets brighter. What happens if we change the resistance? If we increase resistance, the light gets dimmer. If we reduce resistance, the light gets brighter. What happens if we take out the resistor completely? Well, the light bulb is very, very bright right now. The light bulb itself does create some resistance. But what happens if we remove the light bulb? Uh-oh, there's a fire. We have created a short circuit. A short circuit is when there's no resistance in the wires whatsoever, and this increases the heat so much that it's a fire hazard. Please don't ever do this. Now we're back to having a regular circuit with two resistors in series. The value of our voltage is currently 10. The value of this resistor is 10 ohms. And let's change the value of this resistor to 90 ohms. Let's add a voltmeter to measure voltage drop across each resistor. If you get a negative value, you simply have the probes in the wrong direction. The voltage drop across this resistor is 1. The voltage drop across this resistor is 9. These values make sense because this resistor is 9 times as large as that resistor. What happens if we make the resistor values the same? Let's make this one 20 ohms, and let's make this one also 20 ohms. Now notice that the voltage drop across this resistor is 5, and the voltage drop across this resistor is also 5. Because they are the same size, they each have half of the voltage drop, for a total of 10 volts.